Hey guys, so we're going to go over the homework from yesterday. So graphing all the other graphs, pretty much graphing everything else. So we're starting with number 1, y equals the tangent of x minus 2 pi. So you still have to come up with your list. So the only thing we don't need is increments. So amplitude, well the amplitude, there is none. The a value is a 1, but with tangent, there is no amplitude. Okay. For the period, remember tangent is pi over b. Well, the b is a 1 in front of that parentheses there that we can't see, the invisible one. So pi over 1 is just pi. And our phase shift, we have a phase shift. And this one is to the right because it's minus, so right 2 pi. And for vertical shift, there's no plus or minus the number after the parentheses, so there is none. So the midline did not move. Okay, and we also need to find our asymptotes. So we find our asymptotes by taking the b times x minus c part, this part right here, and we set it equal to plus or minus pi over 2. So we're going to have x minus 2 pi equals plus or minus pi over 2. Okay, so we're going to need to add 2 pi to both sides. Actually, I'm going to rewrite it so that it's in front. So I'll have x equals 2 pi plus or minus pi over 2. And then I'm going to need to get a common denominator. So I'm going to have to multiply top and bottom by 2 here. So I'll have 4 pi over 2 plus or minus pi over 2. So the two asymptotes are going to be, let's draw little up arrows. 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. 4 pi over 2 minus 1 pi over 2 is 3 pi over 2. So we're going to count by pi over 2's on our graph. That's how we're going to increment it. So our asymptotes kind of tell us how to break it up. And now we're ready to graph. So obviously there's not enough room on this paper to graph anything, so I have some graph paper ready. Now you don't need graph paper. If you don't have it, no big deal. You can use lined paper because that's better than nothing, but try to keep things as neat as possible. So, okay, so this is tangent, and I need more of the positive side since I have asymptotes at 5 pi over 2 and 3 pi over 2. Okay, so let's remember we have asymptotes at 5 pi over 2 and 3 pi over 2. Okay, so I'm going to draw my graph, try to draw straight lines as best as I can. Okay. So I like to space things out because I want things to be super neat, just like I did when I showed you how to graph sine and cosine. So I'm going to let every 2 spaces be a mark. And remember, because I have 5 pi over 2 and 3 pi over 2, I'm going to increment it by pi over 2. So I'll let this first mark be 1 pi over 2. 2 pi over 2 is the same as pi. And then 3 pi over 2. 4 pi over 2 is the same as 2 pi, and then 5 pi over 2. Okay, and we have vertical asymptotes at 5 pi over 2 and 3 pi over 2. Okay, and remember, you find the point in the middle, and you hug the wall going up on the right and hug the wall going down on the left. You get to fake that part of the graph. But this is only 1 cycle. I need 2 cycles. So I need to figure out where another asymptote would go. I could keep going to the right, or I could go backwards and go to the left. I'm going to go to the left since I don't have to draw any more graph. I could just go this way where I have some graph that I could use. And I know that these 2 asymptotes are 2 units apart. So let's go 2 units apart in the other direction. So that means I have another asymptote at pi over 2. Okay, so plot a point in the middle, hug the wall going up on the right and down on the left. And there is tangent. what was it? It was y equals tangent of x minus pi, or x minus 2 pi. Okay, so that was number 1. So I'm going to go back to the worksheet. Number 2, another tangent graph. So let's go ahead and make our list. We have amplitude, which is a trick question because there is none with tangent. The period is pi over b. The b value is that invisible 1 again, so it's just pi over 1, which is just pi. Phase shift, well, it's minus pi over 3, so that means we're going to the right, pi over 3. There's no plus or minus a number after the parentheses there, so for vertical shift, there is none, okay? And let's go ahead and find our asymptotes. So we find our asymptotes the same way we did in number 1. We take the b times x minus c part, that's right there, and we set it equal to plus or minus pi over 2. So x minus pi over 3 equals plus or minus pi over 2. So I would have to add pi over 3 to both sides. So instead of writing plus pi over 3 plus pi over 3, I'm just going to skip to the next step and put x equals pi over 3, because you put it in front of the plus or minus pi over 2. And we're going to need to get a common denominator. That common denominator is going to have to be a 6. So we're going to have to multiply this one top and bottom by 2, and this one top and bottom by 3. And we'll get 2 pi over 6 plus 3 pi over 6. Well, let's do the plus and minus. So the plus 1 would be 2 plus 3 is 5, so 5 pi over 6. The minus 1 would be 2 pi over 6 minus 3 pi over 6. 2 minus 3 is negative 1, so negative pi over 6. Okay? So those are my asymptotes, which means I'm going to count by pi over 6 on my graph for this next one. Okay? The asymptotes kind of tell us how to increment the graph. All right, so I have enough information. I am ready to graph, so I'm going to go to the graph paper. Number 2. Okay, and let's see, I'm going to need more on the negative side this time. Oh no, yeah, I'm going to need more on the negative side. So I'm going to put mine in the center this time. And I'm still going to space it out every 2 lines. So we're going to have 1 pi over 6. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 doesn't reduce. And I can stop there because remember my asymptotes are at 5 pi over 6 and negative pi over 6. Okay? On the other side, I need some on the negative, so I'm going to have negative pi over 6. And then it's just the same, but negative on the other side. Negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6. Might as well keep it equal. Okay, so we have an asymptote at positive 5 pi over 6. So I'm going to draw my vertical line right here. Okay. And I also have an asymptote at negative pi over 6. So they're pretty far spaced apart. So we need to graph a point exactly in the middle. So this is 1, 2, 3, 4, 5, 6 units. So that means half of 6 is 3. 1, 2, 3. So right there at pi over 3, 0 is where I'm going to plot that point. And then fake it till you make it. Hug the wall going up on the right. Hug the wall going down on the left, and there is tangent. But again, oops, the wall is over here, so actually, I'm gonna fix this. It should be hugging that wall. So pretend that that's not there. All right, so this is only one cycle. I need another cycle. So since I have some room on the negative side, I'm gonna I'm gonna graph another asymptote. So let's see how far these are apart. So how many units? 1, 2, 3, 4, 5, 6. Okay, so I need to go 6 this way. 1, 2, 3, 4, 5. I need more. I need one more. 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So that would be negative 6 pi over 6 is the same as negative pi. Negative 7 pi over 6 doesn't reduce. Okay, so I have another asymptote right there. And in the middle, half of 6 is 3, so 1, 2, 3. So at negative 2 pi over 3. Hug the wall going up on the right. Hug the wall going down on the left. And there's our graph. Okay, so on to number 3. So I'm back to the worksheet. And it's still tangent. Y equals negative 1/2 tangent of x minus 1. So again, when we make our list, because you always have to do this, the amplitude is none. The period, well, the b is that 1 in front of the x, the invisible 1. And the period for tangent is pi over b, so it's just pi. Pi over 1 is pi. Phase shift, well, there's no parentheses. So we're not going left or right, so there is none this time. And then for the vertical shift, we do have one. It's at -1, so we're going down 1. So our midline has moved, so we have to make sure that we mark that, and I like to use a highlighter for that. Okay, we need to find the asymptotes. So we take the b times x minus c part. And here's where it might get a little bit confusing, because the b times x minus c part is just this, which means it's just a 1x. So we set x equal to plus or minus pi over 2. So my asymptotes are at positive pi over 2 and negative pi over 2. So I didn't even have to do any work for that. So that was actually really easy. Okay, so I am good to go back to the graph paper and graph number 3. I think I have room down here. Okay, so for number 3, okay, I'm gonna draw right here. And put that in. Okay. And because the asymptotes are plus or minus pi over 2, I'm going to count by pi over 2's, obviously. Okay. So I like to space it out like I said. So 1 pi over 2, 2 pi over 2 reduces to pi, 3 pi over 2, 4 pi over 2 reduces to 2 pi. And I think I'll stop right there and then do the same thing on the other side, but just that it's negative. Okay, and our midline got moved, if we remember. Where did it go? Down 1. So we need to mark that midline on our graph. So I'm going to use this yellow highlighter, and I'm going to put down 1 will be down at -1 now. So I guess I should put a positive 1, keep it equally balanced. And I'm going to mark the midline like so. So when we plot a point, last time it was on the x-axis for the last 2 problems. So when we plot our point in between the asymptotes, it'll be on that midline. Okay? All right, so now let's plot our asymptotes. So we have an asymptote at positive pi over 2 and at negative pi over 2. Okay, so let's find the point exactly in the middle. And so let's see, this is 2 units apart from the midline, 1, 2. And so exactly in the middle would be right here. So hug the wall going up on the right, hug the wall going down on the left. And there is 1 cycle. We need 2 cycles. So I could put a cycle to the left, I could put a cycle to the right. It doesn't matter, okay? But you need to have 2 cycles. So let's see, it's 2 units apart, so I can go 2 units this way. And there is my next asymptote at 3 pi over 2. Plot the point in the middle, which would be at pi, but on the midline. Hug the wall going up on the right, hug the wall going down on the left. And there's number 3. Okay, out of room on this side, so I'm going to go ahead and flip the page to get ready for number 4. Actually, because it bled through, I'm going to use a fresh sheet. So yeah, I'm going to waste paper. What if? Okay, number 4. Okay, this time it's not tangent, it is cosecant. So when we are graphing cosecant, remember we are supposed to graph the sine wave first because cosecant and sine are reciprocals of each other. And then we flip the waves between the asymptotes that we're going to make. So let's start with our list. We need amplitude, which in this case is a 1. The period, remember, is 2 pi over b. Oh, we got to factor out that 3. So when we do that, we'll have cosecant. Factor out the 3, means divide out the 3. So 3x divided by 3 is just x. Pi divided by 3 is just pi over 3. Okay, so the period is going to be 2 pi over 3. And for phase shift, it's minus pi over 3, so we're going to the right, pi over 3. And there's no vertical shift. Okay, so actually VS, vertical shift, none. Okay, all right, and then also we need our start and stop, but I'm kind of out of room here, so I'm going to do that on the graph paper. And remember, when we find our start and stop, we set the b times x minus c, so this part, the 3 times x minus pi over 3, set it equal to 0 for the start, set it equal to 2 pi for the stop. So I'm going to go to the graph paper now for number 4, and let's find our start and stop. Okay, so we have to take the 3 times x minus pi over 3, set it equal to 0 and solve for x. And take the 3 times x minus pi over 3, set it equal to 2 pi, and solve for x. Okay, so remember, don't distribute the 3. There's another way that you can handle this. Just divide out the 3. So divide by 3 on both sides, and you'll get these to cancel, so you'll have x minus pi over 3 equals 0. Add pi over 3 to both sides, and you get x equals pi over 3. So that is where we're starting at. The stop, we follow the same steps, so divide out the 3, don't distribute it. And we'll get x minus pi over 3 equals 2 pi over 3. Add pi over 3 to both sides. So it'll cancel out here, and then 2 pi over 3 plus 1 pi over 3 is 3 pi over 3, but the 3's cancel, so it's going to end at pi. And then we need to find our increments, and remember, I like to do that in pencil, so I have a pencil right here. Hopefully it has lead, because my son likes to play with these. Okay, so start with pi over 3. Oh, we forgot to write the increments. So if we go back to our sheet here, the increments are where you take the period, 2 pi over 3, and you divide by 4. So if you divide by 4 over 1, you're multiplying by 1/4, because dividing fractions is easy as pi. 2 cancels with the 4, so we'll have 1 pi over 6. So it's in increments of pi over 6. Okay, so here's my start, and I'm circling it, and I have to add pi over 6. Okay, I'm gonna have to get a common denominator, so I have to multiply top and bottom by 2, because it needs to be a 6. 2 pi over 6 plus 1 pi over 6 is 3 pi over 6. Okay. And that reduces to pi over 2, which I'll circle, and then add another pi over 6. 3 pi over 6 plus 1 pi over 6 is 4 pi over 6, and that reduces to 2 pi over 3, and I'll circle the reduced form. Add another pi over 6. Remember, there should be 5 marks, and we have 3 so far. 4 pi over 6 plus 1 pi over 6 is 5 pi over 6, and the next one should get us to pi. Add another pi over 6. 5 pi over 6 plus 1 pi over 6 is 6 pi over 6, which reduces to pi. 1, 2, 3, 4, 5. So we have our increments. We are ready to graph. Okay. So for this graph, it's all on the positive side, so I don't need really much on the negative side of the graph. So I like to plan ahead, so that's why I talk through that. So I'm going to draw my vertical axis right here. Was there a vertical shift at all? No, there was not. So the midline is still the x-axis, so that's good. Good to know. Okay, and I'll let this be 1, this be -1. And here are our increments. We need pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and then pi. So actually I made it too long, but that's okay. There's nothing wrong with that. All right, so my midline is the x-axis, because it wasn't shifted up or down. Okay. This was cosecant, so sine and cosecant are related. So we're going to start at pi over 3 on the midline. And then we go up the amplitude at the next point, back down at the next point, down one below at the next point, back up. So here's our sine wave. Okay, remember this is sine. Okay, and remember from here we have to mark the vertical asymptotes. So that is where there are points that are on the midline. So there's a point on the midline, so there's a vertical asymptote. Here's a point on the midline. And here's a point on the midline. Notice that automatically gives us 2 cycles like we need. Perfect. And now we just have to flip the waves. So for this hump right here, I'm using that as my vertex, and then I basically hug the walls to make my parabola. And then use that as my vertex, hug the walls to make my parabola. So pretend that that purple sine wave is not there, and all you see is just a parabola up and a parabola down. That's the graph of cosecant. Okay, so that was 4. If we go back to number 5, y equals cosecant of x plus pi over 6. And I want to change colors. I want to use blue this time. And plus 1. So let's see. Remember, cosecant is related to sine, so we're doing another one of these. So the amplitude, the a value is a 1. Amplitude is 1. The period is 2 pi over b, and b is 1 again. So 2 pi over 1 is just 2 pi. Let's not forget the increments this time. Increments are 2 pi divided by 4, and that reduces to pi over 2. For phase shift, it says plus pi over 6. That means we're going to the left, pi over 6. And we do have a vertical shift this time. We're going up 1. So our midline has moved up a level, up 1. Okay, we're going to need to do our start and stop. I'll do that on the graph paper like I did for the last problem. Okay, and so I just want to get it set up. Okay, sorry. Number 5. Let's take care of our start and stop. So for our start and stop, we take the b times x minus c part, so the x plus pi over 6, and we set it equal to 0 and then equal to 2 pi for our start and stop, respectively. Okay, so it was x plus pi over 6 equals 0, and x plus pi over 6 equals 2 pi. Subtract pi over 6 from both sides, x equals negative pi over 6. There's my start. Subtract pi over 6 from both sides. I'm going to have to get a common denominator. It has to be a 6, so multiply top and bottom by 6. So I'll have 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. Okay, so there's my start and my stop. Remember, the increments were, on my paper I'm looking, I see pi over 2. So I'm pulling out my pencil again. So I know I'm starting at negative pi over 6 and I'm adding pi over 2. I'm gonna have to get a common denominator. So I'm gonna have to multiply top and bottom by 3 because it's gonna have to be a 6. So let me circle, that's my first mark. So negative 1 pi over 6 plus 3 pi over 6 is going to be 2 pi over 6. Which reduces to pi over 3, and I'll circle that. Okay, 2 pi over 6, well, if I use the reduced form or the bigger form, I'm still going to have to get a common denominator with the pi over 2 that I have to add, the increment. So I'm going to keep it as, what is this, 3 pi over 6, and keep it in the unreduced form to save me some extra work, just doing it over and over again. So 5 pi over 6, that doesn't reduce, so there's my third mark. And since it's over 6, let's add another 3 pi over 6. Same as pi over 2 when you reduce it. And we get, I'll put it over here, 8 pi over 6, which reduces to 4 pi over 3, and I'll circle that. There's my fourth mark. Add another 3 pi over 6, and we get what we want, the 11 pi over 6. Woohoo! So we have our 5 marks, and we are ready to graph. So I'm going to put the graph over here for number 5. And here we go. I did need one on the negative side, so I want to make sure I have room on the negative side. Okay, so I'm going to have, let's see, I'm going to have negative pi over 6 and then to pi over 3. So I think this is what I want to do. I want to put negative pi over 6 right here. And then we'll put pi over 3 right here. And then every 2 lines. So 5 pi over 6. And 4 pi over 3. Sorry, I lost my spot. I was like, where'd it go? And then 11 pi over 6. Okay. Remember, the midline moved on this one, I believe. It moved up 1. So we'll have 1 up here and keep it equally balanced. Have a negative 1 down there. Midline moves, so let's go ahead and graph that. Use my highlighter. Okay. And the sine wave is starting at negative pi over 6. So I want to use a different marker. So on the midline at negative pi over 6, we start at a point on that midline. And then we go up the amplitude. What was the amplitude? It was just a 1. So we're just going up 1 above, so I need a 2 up here. So up 1 above, so I'm up here, back down to the midline, 1 below, back up to the midline. So here's my sine wave, but remember, we're graphing cosecant. So that means now I gotta find all the vertical asymptotes. So they would be at the points that are on the midline. So I have 1 at negative pi over 6, 1 at 5 pi over 6, and 1 at 11 pi over 6. And that will give me 2 cycles that I need. And then flip the waves. Parabola facing up right here, parabola facing down right here. And there is the cosecant. Okay, that was number 5. So next page, because I'm out of room now. Let's look at number 6 and make our list. It is secant this time. Secant is related to cosine. So we have to remember we're graphing cosine this time and then flipping the waves. But let's still make our list. So the amplitude is a 2. The period, and this one is being reflected. That's what that negative means. The period is 2 pi over b. This time the b value is a 3. So it's 2 pi over 3. Phase shift. There is a phase shift. It's minus pi over 2, so that means to the right, pi over 2. And there's no vertical shift. So vertical shift, none. Okay. Oh, shoot, I forgot the increments. So the increments are you take the period and you divide by 4. So 2 pi over 3 divided by 4. Dividing fractions uses pi. Flip the second and multiply. So I'm multiplying by 1/4. And this becomes pi over 6. So we're going in increments of pi over 6 again. All right, our start and stop is going to have to do with taking the b times x minus c and setting that equal to 0 for the start and equal to 2 pi for the stop. And we'll go to the graph paper for that. So this is number 6. And let's get ready for our start and stop. So the b times x minus c was 3 times x minus pi over 2. Set it equal to 0 for the start. And 3 times x minus pi over 2, set it equal to 2 pi for the stop. Remember not to distribute the 3's. You can get rid of them by dividing them. So divide both sides by 3. And we'll have x minus pi over 2 equals 0. Add pi over 2 to both sides, and our start is at pi over 2. Our stop, follow the same steps, divide both sides by 3. You'll get x minus pi over 2 equals 2 pi over 3. This should feel familiar because we did something very similar in one of the other problems that we literally just did. Add pi over 2 to both sides. So it'll go away here, but it'll be on this side. Got to get a common denominator. It's going to have to be a 6. So you have to multiply this one top and bottom by 2. This one top and bottom by 3. So we'll get x equals 4 pi over 6 plus 3 pi over 6 is 7 pi over 6. Okay. So we have our start, we have our stop. Okay. And what did oh, okay. I'm just looking at what I have in my key, and I was like, what was I doing over there? But no, I got it right. Okay. So anyways, we have our start and stop. Now we need our increments. So back to my pencil. Okay. Remember, what were we adding? Pi over 6. So we start with pi over 2. It's my first mark. And we're adding pi over 6. So again, with the common denominator stuff, so I'm going to have to multiply this one top and bottom by 3. So 3 pi over 6 plus 1 pi over 6 is 4 pi over 6. And that reduces to 2 pi over 3. There's my second mark. Add another pi over 6. We get 5 pi over 6. There's my third mark. Add another pi over 6 to that. 5 pi over 6 plus 1 pi over 6 is 6 pi over 6, which reduces to pi. So there's my fourth mark. And then add another pi over 6. 6 plus 1 is 7, so 7 pi over 6. And there's our stop. So we have our 5 marks, and we are ready to graph that. So I'm going to fit it in here. Okay. So let me zoom out. And I want it right here. I have this line on my table, so it always messes up my drawings. Okay, so let's see. I need pi over 2, 2 pi over 3, 5 pi over 6, 5 pi over 6, then pi, and then 7 pi over 6. Okay. The midline, did it have a midline move in number 6? No, there was no vertical shift. So I'm just going to put the generic 1, -1, and mark my midline. The midline is on the x-axis because it didn't move. There was no vertical shift. Okay. And so let's see. This was cosine, right? Because the graph we're supposed to graph is secant. So I'm graphing cosine for right now. And it was negative. So we're going to have to flip the waves. So I'm actually going to start in pencil because we're going to be changing what we're doing. All right, so cosine always starts the amplitude above the first point, and the first point is going to be at pi over 2, but we start up above because sine starts on, cosine starts up above. And then we come back down, down below. Oh, wait a minute, I already messed up. Good thing I did it in pencil. The amplitude is 2. I need to go up 2, not up 1. So I need a 2 up here and a -2 down here. Okay. Ooh, that would have been bad. Okay. So back to my pencil. So it's the amplitude above, so I'm up at 2. Back down to the midline. Down 2, back up to the midline. Up 2. Okay? Now, I'm not going to graph the wave yet because remember, it was -2 secant of 3. So that means we have to flip, we have to reflect the points over the midline. The ones on the midline are still going to be on the midline. So these points are still going to be there. But these ones that are off the midline, they're going to be reflected to the other side. So this one, now I'm going to use my pen. This one gets reflected down here. This one's still there. This one gets reflected up above now. This one's still there. And this one gets reflected down below. So it's actually going to go I hit that line on the table. Okay. And remember the vertical asymptotes that we have to graph. They're at the points always that are on the midline. Now here's my problem with this graph. I only have 1 cycle here. I need 2 cycles. So I need another asymptote graphed. So let's see, these are 2 units apart. So I need 2 units apart either to the left or to the right. I'm going to go to the left because, well, I guess I could go either way. It really doesn't matter. I have enough room on either side. If I go to the left, my asymptote is going to be on the y-axis, which is totally okay. And and I already know that this is going to continue up this way, so I'm basically using this wave right here. So I'm going to use this wave and this wave. And flip the waves. Use that as a vertex. And hug the walls on each side to make the parabola. Use this as a vertex, hug the walls. And there is the secant graph. Okay, that was number 6. Number 7, it says cotangent. Okay, so looking at cotangent, remember cotangent and tangent are reciprocals of each other, and they also follow along with the same rules. And so we know if tangent doesn't have amplitude, that means cotangent doesn't have amplitude either. Okay. The period is the same process for tangent. It's pi over b. Now the phase shift and everything's hidden because that 3 is inside the parentheses, so we need to factor that out. So when we factor that out, that would be y equals cotangent of 3 times, and then, so 3x divided by 3 is x. Pi divided by 3 is pi over 3, so plus pi over 3. If you don't do that, you're going to get your phase shift wrong. So the period is pi over b, so in this case, pi over 3. B and 3 rhyme. I also need the phase shift. There's no increments here. Oops, phase shift. And it's plus pi over 3, so it means we're going to the left. Pi over 3. And there's no vertical shift. So vertical shift is none. Okay? And we need to find our asymptotes, so that's where we take the b times x minus c, and we set it equal to, now for tangent, it was plus or minus pi over 2. For cotangent, it's plus or minus pi. So we'll take 3 times x plus pi over 3 and set it equal to plus or minus pi. Okay? All right, remember, you still do not distribute the 3. The number in front you do not distribute. We have to divide it. So divide both sides by 3. So we'll get x plus pi over 3 equals plus or minus pi over 3. And then we need to subtract pi over 3 from both sides, so we'll have x equals negative pi over 3, because we put it in front of the plus or minus pi over 3. So we're going to get 2 asymptotes. So negative 1 pi over 3 plus 1 pi over 3 is 0. Negative 1 pi over 3 minus 1 pi over 3 is negative 2 pi over 3. So these are my 2 asymptotes, 0 and negative 2 pi over 3. So because of the 2 pi over 3, we're counting by pi over 3. Okay? So I'm going to go back to the graph paper, and we're going to have number 7. Okay. And I just want to pull it up on my key, make sure that I don't screw it up, because it's like my security blanket here. Okay, so our asymptotes are at x equals 0 and negative 2 pi over 3. So I'm going to need some on the negative side, and I'm counting by pi over 3s. Okay, these are my asymptotes. And so since I need some on the negative, some on the positive, I'm going to draw this in the middle. There was not any vertical shifts, so the midline did not move. Okay, and so I'm going to go focus on the negative side first. So it goes 0, and then negative 1 pi over 3, negative 2 pi over 3, and I can stop there. Oh, I might do one more. Negative 3 pi over 3 reduces to negative pi. Then on this side, I will have 1 pi over 3, 2 pi over 3, and positive pi. Okay. The midline did not change. It is still on the x-axis, so I'm going to mark that there. Okay. And, okay, so let's plot the asymptotes. So I have one at 0, so that's the y-axis pretty much. And I have one at negative 2 pi over 3. Remember, cotangent has a hidden asymptote in the middle. So in the middle between negative 2 pi over 3 and 0 is negative pi over 3. So we need to plot the hidden asymptote one. So I'm going to put hidden, so one exactly in the middle. Okay. All right. Now we just have to plot a point in the middle of these two asymptotes and in the middle of these two asymptotes. So there's one here. And we do the reverse. So you know how tangent goes up on the right, down on the left? For cotangent, it goes up on the left, down on the right. Plot it in the middle. Hug the wall up on the left, down on the right. And there is our cotangent graph. So that was number 7. Okay. Out of room, and I need more graph paper, so let me just grab that real quick for you guys. Okay, back to the worksheet. Number 8, we have y equals cotangent of 1/3 x plus pi over 6 minus 1. Before we do our list, automatically, first of all, it's another cotangent. Second of all, we're going to need to factor out that 1/3, so we need to do that first. Okay, so we're going to have y equals cotangent. Factor out the 1/3, that's our b. 1/3 x divided by 1/3 is just x, plus pi over 6 divided by 1/3. Okay, so pi over 6 divided by 1/3. Dividing fractions easy as pi, flip the second and multiply. So we have to flip the 1/3, 3 over 1. 3 goes into 6 twice, so this is just pi over 2. So it's x plus pi over 2. Okay, so don't forget the dividing fractions rhyme. You use it a lot, okay? All right, so let's come up with our list. The amplitude, it's cotangent, so there is none. The period is pi over b, so that would be pi divided by 1/3. So dividing fractions easy as pi, flip the second and multiply, so our period is 3 pi. We don't need increments for this one. For the phase shift, it's plus pi over 2, so we're going to the left, pi over 2. And we do have a vertical shift this time. We are going down 1, okay? And we need to find our asymptotes. So this is where we take the b times x minus c and we set it equal to plus or minus pi because it's cotangent. So 1/3 x plus pi over 2 equals plus or minus pi, okay? All right, so I need to get rid of that fraction. So to get rid of a fraction, we multiply by its reciprocal. So I have to multiply by 3 on both sides. So I'll get x plus pi over 2 equals plus or minus 3 pi. Then I need to subtract pi over 2 from both sides. So I'll have x equals negative pi over 2. You put it in front of the plus or minus. We're going to need to get a common denominator so that we can add and subtract these fractions. So I'm going to need to multiply this one top and bottom by 2. So that'll become 6 pi over 2. And let's find our two asymptotes. Negative 1 pi over 2 plus 6 pi over 2 is 5 pi over 2. Negative 1 pi over 2 minus 6 pi over 2 is negative 7 pi over 2. Okay? So because of the pi over 2's, that's what we're going to be counting by. Okay? And because it's cotangent and we have this high positive or high negative number, high positive number, there's going to be a lot of increments in the middle. So we're going to need to make sure we have plenty of room on our graph because these are going to be spaced out. But remember, cotangent has a hidden asymptote. There's going to be one directly in between these two. Okay? So let's go to our graph. All right, number 8. And remember the asymptotes were 5 pi over 2 and negative 7 pi over 2. There's a hidden one in between though. And we're counting by pi over 2's. So I'm going to draw my graph in the middle. Let's see, and our midline did move, but our amplitude, there's no amplitude, so I don't even need to worry about that. So our midline did not move. Oh, no, it did. Went down 1, sorry. Okay, so I'm going to put 1 up here, 1 down here. All right, our increments. Because I want to make sure I have enough room, I'm not going to space it out every 2 lines on the x-axis this time. So we have 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2. I guess I could have spaced it out a little bit more, but that's okay. And then do the same thing on the negative side. Negative pi over 2, negative pi. Negative 3 pi over 2, negative 2 pi. Sorry if you can't see this, the marker bleeds a little bit. Negative 5 pi over 2, negative 3 pi, negative 7 pi over 2. Okay, before we do anything else, let's remember the midline got moved. Oh, focus, dude. Okay, it got moved, so it went down one. So I'm marking my midline down here. Okay, and so when we plot points, it's going to be on this line, not on the x-axis. All right, we had asymptotes. We had an asymptote at positive 5 pi over 2 right here. And we had an asymptote at negative 7 pi over 2 right here. Okay. All right, so remember there is one hidden that is exactly in the middle. So how many units is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of 12 is 6. So 1, 2, 3, 4, 5, 6. I'm at negative pi over 2. Guys, can you knock that off, please? All right, so halfway in the middle between here, I'm going to plot a point, and I know that this is 6. Half of 6 is 3. 1, 2, 3. And it's cotangent, so I hug the wall on the left going up, hug the wall on the right going down. 1, 2, 3. Hug the wall going up on the left, hug the wall going down on the right. And there's cotangent. That was number 8. Back to the worksheet. Number 9. Okay, so we have just a graph, just a typical sine graph. So this is just review and graphing sine. So we have amplitude, which is negative. Well, actually, you take the absolute value, so just the 2. The negative just means we have to reflect. The period is 2 pi over b. The b is 2, so it's 2 pi over 2, which reduces to pi. The increments, we divide the period by 4, so pi over 4. The phase shift is minus pi over 4, so we're going to the right. Pi over 4. Knock it off, Luke. And we do have a vertical shift, and it's going up to, sorry if I yelled it into the mic. I didn't mean to get that close when I yelled. Okay, so we got all of our lists. Now we need our start and stop. So where'd my purple pen go? All right, so the start, I think I can fit it. I'll fit it right here. So you take the b times x minus c, and you set it equal to 0. So 2 times x minus pi over 4 equals 0. Divide both sides by 2. Remember, don't distribute. And then we get x minus pi over 4 equals 0. Add pi over 4 to both sides, and x equals pi over 4. So we're starting at pi over 4. And then for the stop, we take the same stuff, 2 times x minus pi over 4, and we set it equal to 2 pi. Divide both sides by 2. 2's cancel. We get x minus pi over 4 equals pi. Add pi over 4 to both sides. That gets rid of it here. We're going to need to get a common denominator. And so I got to multiply top and bottom by 4. 4 pi over 4 plus 1 pi over 4 is 5 pi over 4. So we're starting at pi over 4. We're ending at 5 pi over 4. So I'll find the increments on the graph paper since I'm out of room now. Okay, so we know that we're starting at pi over 4 and my increments are pi over 4. So I'm going to add pi over 4 each time until I get to the end. Okay, all right, so to the graph paper, number 9. Remember, we're starting at, I always use pencil. Starting at pi over 4, I'm going to circle it because that's my starting point. And I'm adding the increments, which is also pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4. That reduces to pi over 2. Add another pi over 4, and we get 3 pi over 4. There's my third mark. Add pi over 4, we get 4 pi over 4, which reduces to pi, fourth mark. and then add pi over 4, and we get our ending point, which is 5 pi over 4, or 5 marks. All right, we are ready to graph. So let's see. For this one, I don't really need anything on the negative side of the x, so I'm going to draw my vertical axis right here. For this one, did we have a vertical shift? Yes, it was up 2. So I don't need much on the negative side, if at all. So I'm going to make it really close to the bottom there. Okay, so we start at pi over 4, and then it was pi over 2, and then 3 pi over 4, and then pi, and then 5 pi over 4. And so, what do I want to space this out? 2, 3, 4. Yeah, I'll have enough room. So 1, 2, 3, 4. I need to go up that high because remember I'm shifting up 2, and the amplitude is 2. So I'm going to be going 2 above and below that midline. All right, speaking of which, let's graph that midline. It moved up 2. That was our vertical shift. So I'm up there. And remember 9 was sine, and it had a -2. That means we're reflecting. So I'm going to start in pencil. So for sine starts on the midline at the first mark. And then it goes up the amplitude, which is 2 units at the next mark. And then back down at the next mark. And then 2 below for the next mark. 1, 2, so I'm down here. And then back up for the next mark. And now I'm going to switch to my pen. Where'd the purple pen go? Okay. And remember, we're reflecting. The points on the midline, right here and right here, they're on the midline, so they're not going to move when you reflect them. The ones off the midline are the ones that are going to move. So this one's going to reflect the same distance, but down here. And this one's going to reflect over and be up here above the midline. So it's going down, up, down. Okay? And this is sine, so we don't have to worry about anything extra. We don't have to flip the waves because this is just our typical reflected sine graph. Okay? All right, back to the worksheet. Number 10, we're graphing cosine. Cosine of 4x plus pi minus 1. Okay, so we're going to have to factor out that 4 because our phase shift is hidden in there. So y equals cosine of 4. 4x divided by 4 is x, plus pi divided by 4 is just pi over 4, minus 1. Okay, so we have amplitude. The a is 1. The period is 2 pi over b, so that's 2 pi over 4, which reduces to pi over 2. And we need increments because this is cosine, and we have to divide pi over 2 by 4, so multiply by 1/4, and that gives us pi over 8. Those are our increments. For phase shift, we have plus pi over 4, so we're going to the left, to the left, to the left, pi over 4. And we do have a vertical shift. It's going down 1. So this has a lot going on. All right, let's find our start and stop. Okay, and for our start, we take the b times x minus c, and we set it equal to 0. So 4 times x plus pi over 4 equals 0. Divide both sides by 4, and we get x plus pi over 4 equals 0. Subtract pi over 4 from both sides, and x equals negative pi over 4. So there's our start. So we're starting on the negative side this time. For the stop, we take the same stuff, but set it equal to 2 pi. So 4 times x plus pi over 4 equals 2 pi. Divide both sides by 4. And we'll get, I'll put it up here, x plus pi over 4 equals 2 pi over 4 reduces to pi over 2. Subtract pi over 4 from both sides. And I'm going to need to get a common denominator. So I got to multiply this one top and bottom by 2. So 2 pi over 4 minus 1 pi over 4 is 1 pi over 4. So there's my start and stop, okay? And the increments, remember, are by pi over 8. Okay, so we'll find increments on the graph paper. So back to the graph paper, I'm going to try to squeeze it in right here. So we'll do my best. Okay, back to the pencil. So the start was negative pi over 4, and the increments are by pi over 8. So I got to add pi over 8. I got to get a common denominator, so I'm going to need to multiply top and bottom by 2. So negative 2 pi over 8 plus 1 pi over 8 is negative pi over 8. Oh, there's my start. So there's my second mark. Add another pi over 8. Negative pi over 8 plus pi over 8, they're opposites, so that equals 0. So there's my next point. And 0 plus pi over 8 is pi over 8. Okay, where am I supposed to stop at? Pi over 4. Okay, so I have to add another pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8, which reduces to pi over 4, my stop. And I have 1, 2, 3, 4, 5. I have all my 5 points. We're good to graph. Okay. All right, so on the graph, let's see, I have one mark that's on the negative side, and but the rest are on the positive side. So I'm going to increment it this way. Oh no, I have 2 that are on the negative side. Okay, so this is how I'm going to do it. I'm going to put it kind of in the middle. Was there a vertical shift? Yes, it went down 1, okay, and the amplitude is just 1. All right, so it went down 1, so I need to move this up a little bit. So I'm going to put it up here. Let this be 1, this be negative 1, and I'm going to have, let's see, 0 is included. Okay, so I'm going to have negative pi over 4, so it'll be over here. Negative pi over 4, then negative pi over 8, then 0, which I didn't really need to put 0 there because we know where it is, and then pi over 8 and pi over 4. Okay, got to mark our midline. So our midline, it was moved down 1, so we're down here. Okay, and this was just a normal cosine graph. It was not reflected, and the amplitude is only 1 unit, okay? So let's start at the first point. So we referenced the midline, but remember, cosine always starts the amplitude above the midline. The amplitude is 1, so I have to be 1 unit above, and then I'm back down on the midline at the next mark, 1 unit below at the next mark, back on the midline at the next mark, and then 1 unit up. So it goes down, down, up, up, down, down, up, up, down, down, up, up. Okay, and there's our cosine graph. All right, so that was number 10. Okay, number 11. Where did I put my paper? How do you determine where the asymptotes go for tangent, cotangent, cosecant, and secant? Well, you have this wonderful asymptotes guide in the notes. So remember, tangent and secant follow the same rules. Their asymptotes are going to be the b times x minus c equals plus or minus pi over 2. So we can say for tangent and secant, it's plus or minus pi over 2 to find the asymptotes. And then remember, cotangent and cosecant went together. So for cotangent and cosecant, it's plus or minus pi. Now, this is just a formality. We do need to remember tangent is plus or minus pi over 2 for its asymptotes, and cotangent is plus or minus pi. But for secant and cosecant, you literally just have to graph the sine or cosine graph and then flip the waves. So you don't really necessarily need to know those for secant and cosecant, but you do definitely need to know them for tangent and cotangent. All right, that is it. Sorry this one's long, but if there were ones that you knew what to do, you could just fast forward. All right, so our test is on Friday. Please plan accordingly for that. You have a testing window from 9 a.m. to 1 p.m. to get it done. After that, that's it. I'm not going to have any makeups for this test, so please plan accordingly. And that's it. So have a good one, you guys, and I will see you in my next video.